All right, we want to go through section 9.2 here. We're going to talk about the zeros of a quadratic function and then the axis of symmetry. We're going to save the vertex of a parabola for tomorrow. We're not going to worry about that at this point. Okay. All right, as you take a look at your guided notes, make sure you get a set of guided notes from the substitute. You probably should have passed those out for 9.2. But here's a couple characteristics of a zero. It is an x value that makes the function equal to 0. A zero of a function is the same as an x-intercept. Okay, so that's where it hits the x-axis. Okay, makes the function 0, hits the x-axis. A quadratic function, okay, remember quadratic function is anything that has an x squared in it, may have 1, 2, or no zeros. All right, now these little graphs aren't on your guided notes. You can put them down if you want, or you can just take a look here. But for a quadratic function, let's take a look at what it means to have 2 zeros. Okay, it means it hits the x-axis twice. Now remember, a quadratic function is always a U-shape. So this U-shape, this parabola, hits once, twice, so we say it has 2 zeros. All right, what would it look like? Whoops, hold on here. What would it look like if it has 1 0? Well, 1 0 means it only hits the x-axis one time. So one case would be a parabola that just hits it at the one point. And how would it look if it had no zeros? Well, no zeros, again, a parabola. And it would just be moved up off the x-axis. Okay, so 3 cases. 2 zeros, 1 0, or no zeros. Okay, that's the only thing that can happen. There's absolutely no way it can hit 3 times or 4 times or 5 times. Just 2, 1, or 0. Now, if you're asked to find the zeros and you're given a graph, all you got to do is tell me those points, where it hits. So right here, and list those as ordered pairs. So the zeros here would be -1, comma 0, and 1, 2, 3, comma 0. That's it. Okay, just find where it hits the x-axis, and then list the zeros as ordered pairs. So -1, 0, 3, 0. All right, the second one here, this hits it exactly one time, so it has 1, 0, and that 1, 0 is at 1, 2, 3, -4, comma 0. Now notice that if a parabola has only 1 0, the 0 is the x-coordinate of the vertex. So if you would take a look at this point here, this vertex would be the point -4, 0. So they serve as the same point. It serves as the vertex and the 0. In that third case here, well, there are no zeros. It does not hit the x-axis. This one opens down, but it does not hit the x-axis, so you have no zeros. Okay, so you have 0 zeros, 1 0, or 2 zeros. Okay, that's the only thing that can happen. Now we want to talk about what's called the axis of symmetry. It is a vertical line. Okay, it's not drawn on the graph. You draw it on the graph yourself, or you just identify it. It divides a parabola into 2 symmetrical halves. Right? The axis of symmetry always passes through the vertex. Okay, and so if you take a look here at this chart, okay, the green line serves as our axis of symmetry. Now when we label this, we label the axis of symmetry, it is always an equation. And so a vertical line always starts with x. So x equals 3. It tells me it's a vertical line. It goes through the point 3 on the x-axis. Okay, that's where the vertex is. Now the vertex doesn't have to be on the x-axis. So right here's my vertex for the second case. We would label the axis of symmetry as x equals -2. Okay, it will not be drawn on the graph. You have to draw it on the graph when it's asked for. So take a look at a case here. Find the axis of symmetry for each parabola. I'm going to draw it in as a dotted line, okay, because it's not actually part of the graph. It's something we added in. So the dotted line. Now right through there, that is going to, so we label the axis of symmetry x equals -1. Make sure you put the x equals. Don't just write -1. Okay, so that is your axis of symmetry. Now for part B here, all right, this one, I mean, it's not too hard to figure out, but it's not on an obvious point. Now the other way to find it, if you're not quite sure, what you do is use the x coordinates. And you take the average of those. Now remember, the average is you add them up and divide by 2. So this has an x coordinate of 1. This has an x coordinate of 4. So if I take 1 plus 4 and I divide it by 2, that is 5 divided by 2, which is 2.5. Now yes, you probably could just figure it out by looking at the graph. But in case they are maybe not at nice points, x equals 2.5. That is the axis of symmetry. Okay, for that. All right, as you take a look at these two, go ahead and calculate, or write down the axis of symmetry. Okay, the one on the left here, C, axis of symmetry, is going to go through that x value right there, which is +1. So the axis of symmetry is x equals 1. Right here, this would be -3. X equals -3. All right, so make sure you, again, label it, have an x equals, because it has to be written as an equation. All right, so now that you take a look at this one here, it says find the axis of symmetry for the graph of this quadratic function. Well, if they give you an equation, life's more difficult. Because if you have a picture, if you have the graph, all you have to do is find the vertex, draw the line through the middle. Here we got no idea. But, luckily, there's an equation that we can use to find the axis of symmetry. So on your sheet, on your guided notes, take a look at that box. And it tells us to find the axis of symmetry, we use this formula. X equals -b over 2a. Well, what's b and what's a? A is always the number in front of the x squared. B is always the number in front of the x. C, which is your constant, doesn't get used in this formula. So if you take a look over here, it says 2x squared plus 4x plus 5. B is the 4. 2 is our a. And we substitute those in, and we get x equals -1. Alright, so if you take a look at the first example, which is the one I actually written up above, okay, it's the same one. So find it for x squared minus 4x minus 10. Alright, so we want to use the equation x equals -b over 2a. Alright, our a value is whatever's in front of the x squared. So there's no number there, but remember that's a 1. B is whatever's in front of the x. You have to take into account the sign. So if it's a minus 4x, we treat that as a -4. Alright, now just substitute in. Now this is a negative, it's always part of our problem. Okay, so that it does not account for the b. So when we put the negative down, since b is -4, I will have minus -4. Then I'll have 2 and a is 1. Well, minus a negative becomes a positive, and so I get x equals 4 divided by 2. My axis of symmetry will be x equals 2. Okay, for that. Oops, hold on. Now for that second one, y equals 2x squared minus x plus 3. So in this case here, a is what's in front of the x squared, which is a 2. B is what's in front of the x, which is a -1. Alright, so we're going to use our equation, x equals -b over 2a. So minus, or the negative, b is negative 1. So you put minus negative 1, a is 2. Minus negative 1 becomes a positive. 2, oh, that should be a 2. A is 2. 2 times 2 becomes 4. That's just 1/4. Just leave it as a fraction. That's fine. X equals 1/4 would be our axis of symmetry. And the last one here, y equals negative 3x squared plus 10x plus 9. Our a value is negative 3. Our b value is positive 10. X equals negative b over 2a. Okay, opposite of b, so you put negative, b is a positive number there, so it's going to be a negative in front of 10, 2 times negative 3. Okay, so it's going to be negative 10 on top. 2 times negative 3 is negative 6. All right, you need to reduce. You also need to simplify, especially the negatives. Do not leave it as a negative over a negative, because a negative divided by a negative is a positive, so that automatically becomes a positive number. 10 over 6 will reduce to 5/3. 10 over 6. 2 will go into 10. 2 will go into 6. 5/3 is your answer. All right, so we did zeros, and we did axis of symmetry. All right, now this is your homework or classwork. If you still have time in class, get started. Page 604, 3 through 12. So just put that with your homework from section 9.1. So I want them both on the same sheet of paper. Okay, your homework from section 9.1 and then your homework from section 9.2, which is this one right here. All right, have a great day, and I will see you everyone tomorrow.